and welcome to our retrofit solutions presentation this afternoon. First of all, I have to say thank you to the Rosenberg Egypt team, Dr. Samir, for the invitation to your amazing country. So I take with me a few positive impressions and very good context, and last but not least, a little sunburn. So let's talk about retrofit solutions. So our target is to replace in that business existing fans, belt-driven fans, with a high energy consumption by low energy consumption EC fan grids. So this is our mission, our target. Well, back in Germany we have a team of 3 colleagues handling almost globally all issues, technical wise, the orders, we do the product management, a little bit of marketing. So we are a small company inside Rosenberg. On the left side, this is Thorsten Kreibel, it is our head of retrofit solutions, my boss. In the middle, this is Patrick Leibersberger. So he belongs 12, 13 years now to Rosenberg. He's coming out of the development, and now we are very happy to have this young, experienced guy in our team. On the right side, well, it's me. When we're talking about the EC fan grid, oh yeah, this is the agenda, sorry I forgot it. So I will talk about the Rosenberg GmbH in Germany, a small presentation about some company facts.
شركة روزنبرج لتحديث نظم التهوية. محاضر فيها المهندس جيريت والمهندس سمير عياد، وتقام في قاعة ورش العمل داخل قاعة المعرض. A workshop entitled Rosenberg Retrofit Fan Solutions, presented by engineer Gierat with engineer Samir Ayad in a workshop inside the exhibition hall.
Yes.
قام الآن ورشة عمل بعنوان حلول شركة روزنبرج لتحديث نظم التهوية. محاضر فيها المهندس جيريت والمهندس سمير عياد، وتقام في قاعة ورش العمل داخل قاعة المعرض. A workshop entitled Rosenberg Retrofit Fan Solutions, presented by engineer Gierat with engineer Samir Ayad in a workshop inside the exhibition hall.
Well, second point is the application area of retrofit systems, how we do the setup of an EC fan grid, and yeah, the advantages. What is your benefit if you buy an EC fan grid? The scope of delivery and the configuration in our software, where we define the right fans for the solution. We call it Rovent 10. Financial support, so this is more the case in Germany. Additional products which belong to the retrofit solutions. So it's not only the fan, there are possibilities by changing the filters into high performance filters, or if you want to have a different cooling system inside. So retrofit is the headline. Then we have a practical example from a police station in Germany about the company. So the company was founded in 1981 by Rosenberg. Last year there was a celebration, 80 years of Rosenberg, and I saw him every day in the company. So he's still in a good condition and every day in the company. So we have around about 45 sales offices on all continents. In Germany we have 450, but nowadays we are close to 500. So the amount of employees is increasing, it's a good sign. Worldwide we talk about 1,500 employees. We have 60% roundabout export share. So this is a rough overview of our products. So here the colleagues from Rosenberg Egypt are more expert in the other products. I'm just here for retrofit solutions, easy favorite. But if you have interest in other products from Rosenberg, please, you are invited to come to our stand. We are not only producing fans, we are also producing air handling units. For the European market, they are coming from east of Germany and in Rosenberg, Egypt, for your market here. Now, this is a picture of our target. We are looking for such fans where we can replace it by an easy fan grid. One example here. You see this fence protecting the air inlet and also this big belt protection. All is disturbing the airflow. And disturbing the airflow means that you need higher pressure, higher volume, more energy, and this all creates a high energy consumption. So we are looking for customers which are running such fans and replace it by an easy fan grid. Yeah, same here. There are many examples, so you know it, what I'm talking about. Old belt-driven fans with 1, 2, 3, 4 belts, for example. So last year we went to a hospital doing an inspection of a AHU, and we saw that the fan was running originally with 3 belts, 1 belt smashed off, and the other 2 belts have to carry the load. They are overloaded, creating friction between the wheels. And if it is creating friction, the energy consumption is going up because the efficiency is going down and the whole system is not running in a good condition. Also, these kind of flaps influencing the pressure. We very often met very old fans where this system is not moving the fans anymore. It's out of order. It stands somehow and the customer even don't know what is delivered by it or what kind of pressure in the airflow is delivered to the rest of the duct. Yeah, so we not only have the air handling unit as a nice module, also there's maybe this kind of ventilation units with the concrete duct. So for us, this is not the limit. We also can install the easy fan grid in almost every application. Well, here you see an easy fan grid. So imagine if you replace an old belt-driven fan with maybe 2, 3, 4, 5 meters length, depends on the power. By an easy fan grid, it's a fan wall. Maximum is 450, 500 millimeters. So you save a lot of space in a new air handling unit as well in an existing. So if you think about putting better filters or more filters or heaters or coolers, and you need more space inside, yes, the space is available if you go for an easy fan grid. You will win, depends on the size, 1, 2, 3 meters. Yeah, this is a special version with the fans. It depends on the security. The security level has to be, so we can also do things like that. It's not a problem. So where does it come from? Grid means net. Yeah. So the construction is like a net, a fan wall. On the right side, you see the air's going inside the sucking side, and on the right, this is the pressure side. The advantages of an easy fan grid. Well, We have improved efficiency, comes from the motor. We don't have the losses of a frequency converter, we don't have the losses of a nominal motor, and we don't have the losses of the belt. Redundancy. That means if one fan fails, broke down, the other fans, the other remaining working fans, they can cover the fan which is going down. And this is now the point when we are in contact with the customer, and the customer says, yes, he needs redundancy, 100%, the unit should go to 0 downtime. Then we can set the operating point with a certain level of reserve. And in case of one fan is going down, the other fans can go up with the speed and cover this fan which is going down. We can also deliver sheet metal plates to cover the hole, that the air is not going in a circle in case of a failure. Yeah, compact and flexible. So one man is enough to install the EC fan grid. The maximum weight I'm talking about is 35, maybe 40 kg for the biggest fan. If you compare to a belt-driven big fan, the motor can weigh hundreds of kg, only the motor. So when we design an EC fan grid, the fans are equally distributed in the channel, so the airflow is very constant and equal. You don't have just one hole where all the airflow and pressure is going through. We use the whole section of the AHU. And there's another point. So on all the belt-driven fans, you see this diffuser on the pressure side to make the airflow on a belt-driven fan equal. So you can get rid of this plate. It's a plate with holes to make the airflow equal. You can get rid of it, and that means you can reduce pressure, needed pressure. This plate often creates a loss of 70, 80, maybe 100 Pascal of pressure. What is the message here? If you reduce the pressure, you reduce the energy consumption. The EC motors have an internal electronic. Normally they are controlled with a 0 to 10 volt signal, and this electronic, it's working like a frequency converter, but it's integrated in the motor. And the signal is going without any losses inside the motor, and the electronic generates the right magnetic field, and the runs per minute in the direction of the magnetic field. Later on there will be an explanation how an EC motor is working. Yeah. Due to the weight, we have an ease of replacement and maintenance. And it's easy to clean. There's no abrasive on the belt. It's clean inside, and you have totally access to the floor, to everything. Remember the pictures of the belt-driven fan? There's a steel construction, there are dampers, and it's not easy to clean. If you think about sensitive areas like hospitals or chemical industry. So with the EC fan grid, no problem. It's clean, there's no belt abrasive, nothing. And if there's no abrasive, you don't even need the filter behind the fan, because this unit here doesn't create any dust, any particles, nothing. Reducing the filter means also reducing the needed pressure. Weight reduction of the whole unit, and yeah, of course, you save a lot of space. This is a well-known AC motor. One information, so our production of the EC motors is directly in the headquarters of Rosenberg in Germany, and this production is now changing. The process started 2 years ago, 100% of production of AC motors. We also produced the AC motors, of course. We need it for some other applications like a kitchen exhaust, for example. This AC production has moved to the eastern of Europe. But in Germany we are producing the AC motors, only AC motors, 100%. Some additional words to the AC motor. So the starter has to be powered by current, then the AC motor is creating a magnetic field. And if you create something, you need energy. Creating magnetic field means losses inside the motor. That's the difference to the DC motor. There we have permanent magnets. Yeah, well, the electronic here getting the signal, the volt signal 0 to 10, or if available a mod-bus signal can also be handled by the electronics. Yeah, here's some figures. So the message here is on the right side, the AC motor is the highest efficiency, and it is measured, it is reliable, and it is, let's say, state of the art nowadays. IE4, we are close to IE5 nowadays with the AC motor. Yeah, when you reduce the speed to 75%, you have more or less the same picture. And at the bottom is, if you want to control an EC motor, there's no VFD needed. The EC motor, this is the potentiometer, giving the signal to the motor. This is the easiest way to control an EC motor. As an option, we have different kind of control units. If this signal, 0 to 10 volt, is not coming from the building management system, if there's no BMS available, we can install potentiometer or our small device to control the EC motors. Talking about efficiency, so this is a real example. So here you see the old version, belt-driven big fan with a high power consumption of 35 kilowatts, and the replacement with the EC fan kit, 9 units, saved around about 13 kilowatts. That means the amortization is done in 2.3 years in that case. Okay, these figures are from Germany. We have much higher cost of energy in Germany. We are paying nowadays close to 40 euro cent for 1 kilowatt hour. Just to compare it. After these 2.3 years, this is the return of investment, then you save money every year. Not only by energy, same for maintenance. You don't need staff who's checking the belt, who's changing the belt or something. Not needed. There is no belt anymore. Sometimes we got asked by customers, hey, could you please do this return of investment calculation? We have an Excel sheet for it, and the customer will get a nice PDF with Rosenberg on it and every information. And here it is important to get some basic information. The running time is one point. The other point is the cost of energy. And is there a VFD or not? Because the VFD also consumes 92-93% the efficiency of a VFD to create the frequency for the belt-driven one. So all these figures are going inside the calculation, and the result is hopefully a nice small return of investment. So here again, a lot of figures. Here's your chip count. So this is an example from a customer from us. So on the left side, you see the EC fan grid. 500 is the diameter, compared to a HRZ 800. So a belt-driven one. The flow rate is the same. The static pressure is the same. Yeah, it's important if you compare something to each other that you have the same operating point, the same pressure. The number of fans, of course, we have 1, and the EC fan grid 4. The absorbed power 11.5 compared to 13.2. On the first view, it is not much, just 2, something like that. But at the end of the day, it is coming additional during the year. So the energy consumed in 16 working hours per day, you see 184 compared to 211. And the kilowatt unit price in Egypt pounds is 1.5. I think that's the current rate. That means that the energy cost per day in Egypt pounds is 276 to 316. That means in 5 years you have savings of Egypt pounds 73,000 for the EC fan grid, just to reduce the energy consumption. Of course, you have 0 on the right side because there's no energy consumption and no energy savings on the right side. The initial cost in Egypt pounds is 277,000 compared to 200,000 roughly. The costs of the cross section is on the left side close to 70,000 compared to 120,000. That means the total fan costs on the EC fan grid side around about 346,000 compared to 324,000. So the message is here that if you have the chance to save a few kilowatts at the end of the year, depends on the running hours of course, and here we only put 16 hours. Sometimes the fans are running 24/7, 100% running through. So here you have to be careful what you put into the calculation. One additional sentence, so every kilowatt counts. Let's talk about redundancy. So in this example, we have 7 fans running with the airflow rate of 70,000 cubic meters per hour. You see on the picture, 2 holes are closed. And yeah, this chart here or this graphic is coming out of our selection software, Rowan 10. So we put there the duty point, and then the software in the background searching for possible models of fans, impeller and motor combinations. And yeah, we have a static pressure of 1,400 Pascal, and it's running at 70,000 cubic meters per hour. So if one fan, say goodbye, is going down, we can close this hole, and the air handling unit is not out of order. It still runs at 60,000 cubic meters per hour. And it depends if there is some reserve left. You see, this is the here the 0 to 10 volt signal, so it's running 8.7 volt maybe, and there is some reserve. So we can adjust the remaining 6 fans to 100% 10 volts. Yeah, and this redundancy, if a belt-driven fan, if the motor is going down, if the belts are gone away, game over. So the unit is not working anymore. And sometimes customers don't have a system to check the belt and the tension of the belt. So the motor is still running, but there's no airflow. And this could be for hours, days, weeks, I don't know. So customers, they don't even recognize that the air handling unit is not working anymore. Let's talk about maintenance. So here, for sure, you have a lot of bearings on a belt-driven fan. Same on the norm motor. And most important, you have to check the belt, the tension of the belt, the condition of the belt. And with the EC fan grid, the belt is not existing anymore. You only have to check, you have to change the bearings after, we say, 20,000 to 40,000 operating hours. So the bearings, we guarantee that the lifetime is minimum 20,000 hours. Yeah, easy to clean. Here you see the belt-driven version. So there's, yeah, honestly speaking, I don't want to clean this room. No chance to go there somewhere. And if you go with the EC fan grid, nothing is on the floor. Just open the door, clean it out. That's it. About the retrofit kit. So Rosenberg is the only supplier which delivers a whole solution. So not only the fans, so we deliver the whole mechanical parts to ramp up this fan wall. So the beams, the C-rails on the floor, the horizontal and the vertical beams, as well as the sheet metals to close the space around the fans. We also deliver, if the customer is going for it, the control box. Some words for the control box. So this 0 to 10 volt signal is going into the control box, and here inside it is divided into the amount of fans, so that every fan is getting the same signal. Yeah, here you see almost all of the parts. It's not magic, it's just sheet metal parts, but the message is here that we are delivering the whole package. So the installers, they don't have to guarantee for the static, for example. They don't have to do the design work to create this wall. Everything is coming on a pallet, like plug and play. Yeah, it's modular, so we have no limits, and it doesn't matter where the AHU is coming from, so we are able to deliver our EC fan grid almost to every supplier of handling units. Yeah, same for the documentation, so the wiring diagram is coming with it, as well as the installation documents. And yeah, if the installers, they have some issues or the assembly instruction is passed away, we are still there. So they can call us, we give some instructions on the phone or via Microsoft Teams or whatever. Yeah, here you see the scope of delivery. So the control box, the fans, of course, the sheet metal parts, and in these boxes there are materials like screws, cables, cable glands, so we deliver everything. As well as the ring measurement system around the fans. So this is needed for the small control device, what is also delivered, I would say close to 100%. We deliver the DPTR control unit. So we are checking the pressure on the pressure side and on the sucking side. And with the K factor, so every fan has a specific K factor, we calculate the air volume. And this small device can control the fan, so if the air volume is going down because the filters are full or some flaps are closed, this small device recognizes the difference and turn or rise the volt signal to the fans to get the old or the defined operating point. So if you want to replace an old belt-driven fan, normally the units are huge. The fans are very big, the motor is very heavy, and we very often face companies in Germany like this picture here. So the space to put the old fan out and carry it away, they are not there. So it's difficult. That means if a belt-driven fan is broken down completely, it's difficult to replace it. In some cases, we have to cut the existing belt-driven fan into pieces and carry it out by hand. Same here. Imagine to install the easy fan grid. It's very easy. One man can handle the fans or the sheet metal parts. You can reach the air handling unit very easy. This is a video about the installation. This is time for me to drink something. Yeah, so we start with the C rails at the bottom and the top. This C rails giving us a solid base to install the fan wall. Then we have the vertical beams, it's like a telescope. After that comes the fan supporting plate. And as I said, every screw is inside. You don't need anything. Just the tools to tighten the screws, of course. So about the installation time, so we calculate a unit with 4 fans, 2 installers, 1 day, with everything, as well as the electrical connection in the control box. So the whole easy fan grid, 2 men, 1 day, 4 fans. I think we could stop here the video. Huh? I think the designer of the video, they like screws. Yeah, this was an example. This was a headquarter, police headquarter. in Germany. So they asked us, or the mission was, we want a high efficient fan, AC fan grid, and due to the COVID, we need a, we call it TBS, so a circulating heat system where the air is not, the supply air is not getting in contact with the exhaust air. It's totally separated. This was the main task of them, and the second was reducing energy by putting an easy fan grid. Yeah. So improvement of the air quality was the priority. Yeah, circulating heat recovery system. I think heat recovery systems are not so common in Egypt, but it also works with cool recovery system. Yes. So this system is produced also by Rosenberg, but not in Germany, it's produced in Hungary. The hydraulic station, we don't produce it by ourselves, we're getting it from a supplier. Yeah. At the beginning of the presentation, I said reducing the pressure is one key to reduce the energy consumption. This is also belonging to the filters. If you go to a high quality filter, you have lower or less pressure losses. At the beginning, you have more investment because the filters are more costly. But at the end, if you save 10, 20, 30 Pascal, you have to calculate it. It's bringing you a huge benefit. Next point is, I said it also, the easy fan grid is, you can show it and you can see it on our stand, 450 mil. That's it, compared to 2 or 3 meters. And to save space, yeah, it's easier to install, easier to transport. And if the air handling unit is 2 or 3 meters shorter, the office next to it can be longer, you can put more employees in and so on. In our retrofit solutions world, we can use the whole portfolio of Rosenberg, and we are not only using the easy fan grid, we are also, for special applications, have the DKNB. So this is a normal motor, powered and controlled by a VFE, and this is for special applications like kitchen exhaust. So kitchen exhaust is there's a lot of fat in the air, and this is not good for EC motors. Therefore, we go with the DKNB, and this is so the it's not on the picture, but there's a housing around the motor, and the motor is cooled by external air, so it's not directly in the airflow. This was a special application. We use here these Excel fans, so high volume, low pressure. This was in the south of Germany. They are producing textile components. Yeah, these parts are produced in Rosenberg, Hungary. So register, coolers, heaters, hydraulic stations, filters. So the retrofit solutions business is covering the whole modernization of a AHU. And one example in Germany, if AHU is completely going down and the customer has to think about buying a new one, or do I have to, or is it maybe better to do a retrofit on the existing one? And yes, if he buys, at least in Germany, a new one, there are new regulations, ERP for example. So if he buys a new one, he has to match the newest or latest regulations. And in 100% of the cases, a new one will be bigger filters, maybe lower air speed. And this is sometimes not possible because there's no space around to make the air handling unit bigger. There's the only way, retrofit, modernization. Yeah, so there's almost no limit. We also can reduce modules if one module is damaged or something. In Germany, we have our own service team. Nice colleague. So we are doing the installation and we are doing the measurement of the old existing air handling unit, because it's happened very often that the customer even don't know which airflow, which pressure, which dimension. So our service is going to the customer, measuring the current status of the AHU, and then these values are very important to design the right DC fan grid. The inner dimensions of the air handling unit, airflow and pressure. That's it. So I'm ahead of time. We still have 15 minutes. So the presentation is over. Thank you for being here. If you have any questions, you can take the chance now to transfer your question to me, or you are invited to our stand for more discussions. Thank you.